good day, geometry. It's been a while, but we're getting back into parallelograms. And today, Gino, warning for you, we're going to talk about the final parallelogram of the unit. And if you just look back, remember this section here, we don't talk about it often, but this section here, the CO section, are all of the previous lessons that our current lesson kind of draws from. For success in this lesson, you need to know everything from Algebra 61, which is simplifying roots, 39, Pythagorean theorem, 41, special right triangles, 42, sine, cosine, tangent, 45, 46, and 47, which are parallelograms, rhombuses, and rectangles. Squares are that awesome, okay? Where they just bring back they have so many mathematical relationships that your success in squares really does require you to know everything from this many lessons. Which is why it's a PO, because of course, why not, right? But let's start by kind of talking about what a square is. And again, it's been a little while, but because a square is a parallelogram, what are those 5 characteristics of every parallelogram, meaning every parallelogram, rhombus, rectangle, and now square has these same 5 things? Drew, give me one.
Opposite sides are parallel.
Opposite sides are parallel. Opposite sides are parallel. It's true for every shape we've talked about so far. It's true for squares as well. Joey.
Another one's opposite sides are congruent.
Opposite sides are congruent.
Thank you.
Again, true for rectangles, rhombuses, now squares as well. Caleb, third one.
Opposite angles are congruent.
Opposite angles are congruent. Okay, what else?
Diagonals bisect each other.
Diagonals bisect each other. And one more, has to do with angles. If you're unsure, just flip back to any of the previous 3 pages. Will, adjacent angles are supplementary. Okay, you've now written these same 5 things 4 times now. It's a key point for all of them. Make sure they get on a help sheet. They will help you kind of identify those relationships. Okay, a square though is extra special because a square is both a rhombus and a rectangle. Meaning every property that we said was special to a rhombus, a square also has. And every property that was special to a rectangle, a square also has. Making a square the most special shape of them all. So what were those 5 characteristics that were unique to either a rhombus or a rectangle that actually a square also shares? Mackie.
All sides are equal.
That was for a rhombus. Okay. All sides are congruent. And that was from a rhombus. What else? Well, diagonals are perpendicular. Which shape was that from? A rhombus as well. I don't really stand on this side of the board too often, but I gotta let my friends see. All right, Drake? Diagonals are congruent. That was from? Diagonals are congruent. That is because of a rectangle. 2 more. Yeah.
Those are 4 right angles.
Sorry?
There are 4 right angles.
4 right angles. That is from a rectangle. And what's the last one?
Diagonals bisect each pair of opposite angles.
Diagonals bisect opposite angles. And that was from a rhombus. So 10 different properties that all squares have. Caleb, what did I not write very clearly?
No, it's fine, I just had to see.
Oh, okay. 10 different properties that all squares have. So you're looking for these angles, looking for these sides of squares. You are looking for right triangles, knowing that the diagonals are perpendicular, like a rhombus creates those 4 right triangles within the shape, and the 4 right triangles within a square. Knowing that all 4 angles are right angles, okay, like a rectangle, you have right triangles on the outsides too. Stuff is everywhere. Okay, very, very powerful shape, those squares. So growing up, if you've ever been called a square, he's so square. I can't think of a better compliment than that. Yeah? Yeah. See, there you go. Okay. Who knew? All this time. Anyone still need the notes? Well, that's a Dwight Schrute. Okay. So here's a square. The only thing that you are given is that this part right here of this diagonal, just that section, is 1. That's the only measurement you have. Okay? And from that, I ask you to find 6 different things and then a math packet type question at the end. So you're looking for angle MKN, LMK, LPK, sides KN, MP, and LP. I'll remind you, okay, where are your right triangles here? This is going to help you. Where are your right triangles? Where are your right angles? Blake? The center. So you've got right triangle here, right triangle there, right triangle there, right triangle there. Okay? Where else? Where else do you have right angles and thus could use right triangles?
Unlike the corners.
The corners, the outside corners. So you have a big right triangle there. You have another one here, that diagonal, here, and here. Okay. One of the objectives that was listed as needing to know was 41. 41 was special right triangles. What special right triangles are going to be present in a square? 45, 45, or 30, 60? 45, 45, right? Since these diagonals bisect each pair of opposite angles, this right triangle here, for example, you got the right angle here, you have a 45-degree angle there, a 45-degree angle there, you got a 45, 45, 90 triangle. Okay? So all these different things come back when dealing with squares. You've got 15 minutes right now to work on this with table mates or with buddies. You can move around and we'll come back and go over some answers when we are done. And here we go. Angle MKN. Let me erase my drawings here. What do you get for angle MKN? Which MKN is this one right here. What do you get? Will? 90 degrees. Okay, that's one of our right angles inside of the triangle. And we know that because the diagonals being perpendicular, they create 4 right angles inside the triangle, MKN being one of them. LMK is the next one. LMK is right here. What'd you get for that one? Drew?
45.
It is 45. Right? If we've got a right angle up top here, and we know that PM, that diagonal, bisects that angle, it means it'll be 45 on that side. And angle LPK. What'd you get for that one? Yeah. 45 as well. Good. 45 degrees there as well. Okay. Now we get to the sides. KN. What's KN? And again, the only side that you're given is LK. What is KN? Why haven't I been watching? What is KN? Miranda? It is 1. Since the diagonals bisect each other, that means that each of these 4 sections here, they're all 1. So MP is going to be, Peter? 2. Good. And maybe the hardest question of the bunch, LP. What did you get for that one? LP. Someone we haven't heard from, perhaps. Joey.
1.4.
How did you get 1.4?
So for Pythagorean
Pythagorean theorem, okay. You can use the Pythagorean theorem. You need 2 of the 3 sides of the triangle. So how would you use the Pythagorean theorem?
since the diagonals are bisected equally, two of the diagonals would be 1. So PK.
Oh, so you were using, I gotcha. So you were using LK and KP as your A and your B, the legs of the right triangle, using LP as the hypotenuse, right? Essentially? Good. Anybody use a different method?
I just use like 45, 45, 90.
You can also use 45, 45, 90. Since you know that LN, the hypotenuse of this right triangle here, LN, that whole thing is 2. What did you come up with for your answer?
1 square root 2.
1 root 2, or since it's 1 root 2, just root 2, right? Which if you take the decimal value of that is approximately 1.4. So Pythagorean theorem, 45, 45. Anyone use sine, cosine, tangent? No? Could you have? Yes. To find that as well. You did? Excellent. Okay. Draw a specific square and rectangle, each with integer side lengths greater than 1 and areas of 16. Which shape has longer diagonals and by how much? So since you have to draw a square with an area of 16, that one is going to be 4 by 4, drawing the diagonals there. Okay. And then a rectangle with side lengths greater than 1 and areas of 16. There's only one option here. What does your rectangle have to be? 8 by 2. And the question is, which one has the longer diagonals and by how much? You can probably eyeball it to see which one has the longer diagonals. Anyone have a guess?
Square.
Oh, really? I guess the rectangle.
No, I think it's a square.
But how can we prove it? What could you do here to calculate? I mean, since the diagonals are congruent, you really only have to find one of them, and then just double that to get the sum of each of them. So what was your method? What did you do? Drew.
Use cosine
Use cosine. And what did you come up with?
for the rectangle.
Yes.
5.66.
I'm wondering how you use cosine without the angle measure. Huh? What angle did you use for cosine?
The far right.
The one up top here?
Yeah.
And what measure did you give it?
45.
Okay, so in a square that would work. In a rectangle it would not.
Oh.
Right? So a square would work, rectangle would not.
Oh,
Yeah.
For the rectangle, I got 8.25.
Okay, and you used Pythagorean theorem. So did we have a second on that? 8.25? Yep. So if one diagonal is 18.25, then the sum of both of them, both diagonals, right, would be 16.5. Since they're congruent, you can just double it. And then for the diagonal length of the square, what'd you get for that one? The diagonal length of the square. John, did you do this one? The diagonal length of the square? What'd you go with that? No? Yeah? 5.66. And you did that using which method? Pythagorean theorem. Anyone use a different method for that one? You could have also used 45, 45, 90. You know, you've got these two congruent lengths here, 4 and 4, which would make that diagonal 4 root 2, which would make the sum of each of them 8 root 2, which is approximately 10 or 11.2, which you got by adding them. You got one diagonal to be 5.66. Yep. And so both of them together would be about 11.2. Well, 5.6 times 2 would only be 11.2, which is approximately the value of 8 root 2. Okay, so either way works. So the rectangles are longer, 16.5, compared to approximately 11.2, by about 5.3 units, give or take. Depending on what method you use, how you rounded, things like that, your answer might be slightly off, but approximately 5.3 is what we are looking for there. Okay. Questions on squares? Comments, concerns, complaints, compliments, congratulations, or criticisms? Thank you. Way to be square. That was directly to you, Greg.
You always like Caleb.
Why? You can always swear. Nathan!
The rectangle.
Yes.
I think it would be. I think when Nene meant the diagonal as in the whole thing, not just half of it, is 8.25.
Yeah, the whole diagonal.
The whole
Yes.
thing.
Yeah.
Yep, so then since you're looking for the sum of them, I guess it's not really clear in the question. I was looking for the both diagonals together and then compare that with, so if you only went with one diagonal, then this answer would be approximately 2.65. Is that about what you got? Because if you went with one diagonal, if you went with 8.25 for just one diagonal, and then one diagonal in the square was approximately 5.66. That's a difference of approximately 2.65, give or take. So if you looked at it as just one diagonal per one diagonal, you would have gotten about 2.65 if you look at it the sum of both of them, which is what I intended, but sometimes my brain does, it'd be 5.3. Thank you though for bringing that up. Okay. Anything else? All right. No homework for tomorrow. Take a look at the math packet. We'll talk about some questions. Then have a wonderful day. That's it, man. Like and subscribe.